Okay, welcome to this week's Megaport live tech drop-in session. The topic for this week is packet filtering on MCR. So this is actually a new feature that's just been added a couple of weeks ago, maybe a month or two. So essentially this is an additional feature that's built onto the MCR product. So it's not a separate product or a standalone thing. It's part of that existing product set. And we'll dig into what that is. We'll first off, we'll have a bit of a look at MCR just to kind of refresh on where it fits in and what customers typically use it for. We will jump into packet filtering specifically, so what this new functionality adds. We'll jump into a demo and then have a Q&A section at the end if we've got anything that we haven't addressed along the way. As usual, if you do have any questions, we have the Q&A panel in Zoom. So chuck any questions in there. We'll try and answer them as we go. Otherwise, if you're watching this later, we upload all of these to the YouTube channel. So feel free to add comments there. We'll come back and try and answer those as well. Otherwise, we should be good to go. I think, yep, cool. All right, so what is MCR? So MCR, Megaport Cloud Router, basically it's the cloud router product that Megaport provides. Although it says cloud, it doesn't have to be used for routing between clouds. That's just probably the most common use case. We basically have some infrastructure that we run in points of presence all around the world. MCR is a virtual router that you can spin up inside of that environment and link to anything else on the Megaport network. So where you need to do layer 3 routing, basically within Megaport, you can use MCR for that. It's designed to be super easy, super low touch, automated, orchestrated, very abstracted. So it's really designed to be as easy as possible, and something you really don't have to worry about or get involved with too much. As I mentioned, probably the most common use case is routing between clouds, so between Azure, AWS, Google, Oracle, and so on. But you can also route between data centers or combine the two, really any time you might need layer 3 functionality within Megaport's network. So one of the use cases we see for that is network optimization, routing optimization. So you might have a situation where your data center is not necessarily very close to the clouds or the other things that you want to route between. So rather than hairpinning that traffic all the way back to the DC, which obviously not only gives you some latency issues because you kind of have to go there and back, but it also means you have to handle all that routing on your own hardware. So you have to have capacity for that. There's potential points of failure. There's costs for those long haul connections as well, if you're pulling traffic over long distances. One of the big use cases we see is customers will drop an MCR into the local environment, sort of geographically local environment where they want to route between things, and it gives them the ability to handle that traffic routing locally without hairpinning back to their own on-prem data center. The other big use cases we see with MCR is oftentimes now customers don't have a data center presence at all. They only exist in the cloud. Maybe that's multiple clouds. So how do you get between them if you don't have a DC to sort of pull that traffic back to? So MCR is really, really commonly used for this sort of situation where you've got multiple different cloud environments. We've got the big hyperscalers here, but we basically connect to all of them. There might be other service providers involved here as well. So different types of voice providers or other types of services that you're connecting into your cloud environments. They can be sort of third-party SaaS and PaaS type services, or voice and video, or storage, or anything like that that you might be able to access via the Megaport marketplace that you need to pull into your cloud environment. You want that private connectivity, you want high bandwidth, you want all the SLAs and all that kind of thing, but you don't have a DC to pull it all back to. So MCR is a really common solution there as well. So that's the existing part. That's the part that's been there the whole time. This new part is that MCR itself can now do some level of firewalling, some level of packet filtering and ACLs. So previously, MCR was very much just a routing product. It was a router. You connect interfaces to it and it routes between them. It didn't really have any built-in um, filtering capabilities. You couldn't really control exactly from a security perspective what connected to what. It does support some route filtering. So you have the ability to um, determine what routes get advertised where. If you don't necessarily want all of the peers on the MCR to receive all of the routes, that's existed for quite a while. But we did have customers who they had architectures with MCR where they needed more fine-grained control over exactly what could talk to what. So they didn't necessarily want everything connected to the MCR to be able to talk to everything else. They wanted to be able to specifically say these different links, these different subnets, these different hosts can talk to these other subnets or hosts on particular ports and things like that. Previously, the solution for this would have been to move to MVE instead of MCR. So MVE is our network function virtualization platform where you can choose your vendor and deploy the vendor of your choice. So what customers have done up till now is if they just need basic routing, they'll deploy MCR. But if they need to be able to do ACLs, they'll basically move to an MVE product and deploy Fortinet or Palo Alto or Cisco firewall or something like that. And that's how they'd get the extra functionality. The caveat there is that in order to do that, although it's definitely a popular solution, it means that you have to take on the management responsibility for that virtual appliance. So it means that if it's a Cisco, for instance, you're then managing that through the Cisco CLI. If it's a Fortinet or a Palo or something, you're connecting that back to your Panorama instance, or you're kind of a lot more hands-on. You're doing firmware updates and that kind of thing. Some customers really want that, and some don't. Some really want the very hands-off cloud-like experience that you get with MCR, but they want to be able to do some ACLs. So that's basically where this functionality came from. Is when you don't want to have to deal with the licensing, you don't want to have to take on full management of an appliance. You just want that sort of one-click, super fast, super simple, hands-off functionality that you get with MCR, but you need to do some firewalling as well. Packet filtering on MCR might be able to sort of fill that gap. As far as the specifics, essentially this is an ACL that you can apply to the VXCs, to the interface of the MCR. So they're applied per interface. It's layer 3 and 4 filtering, so there's no intrusion prevention detection. There's no layer 7 filtering, application identification, that kind of thing. If you want that type of functionality, you'd still look at MVE essentially, because you'd probably be chasing that more next gen firewall, UTM type advanced firewalling functionality, and you'd select a vendor based on that. But if you just need to do basic layer 3 and 4 firewalling and ACLs, that's definitely where this can fit in. At the moment, it's stateless, so we at the moment can't do stateful filtering on the MCR. So these are stateless ACLs. So keep that in mind as you apply these. Basically, the difference there between stateless and stateful, that's a general thing. It's not a Megaport specific thing. And really what it means is that with a stateless rule, you're applying these filters. The appliance will look at traffic as it crosses the ACL and figure out whether it's allowed or not. Whereas with stateful, in addition to seeing whether that traffic should be allowed or not, the device will remember that traffic. And then when the return traffic comes back in the other direction, it'll automatically be allowed because the firewall knows that it's associated with a session that it already allowed previously. Whereas with stateless ACLs, you do have to actually allow that return traffic. So if you allow traffic outbound in one direction, say you allow servers internally to connect out to port 80, then that return traffic that comes in from port 80, you also have to allow that on the other end. So keep that in mind. The packet filters the lists, the packet filter lists, which is sort of the name that we've given to the ACLs themselves, are created at the MCR level. So they're not created within the interfaces, within the VXCs, but actually at the top level, at the MCR level. And that lets you then apply those to the interfaces, to the VXCs. And so you can reuse them. You sort of have a central place to keep all of the ACLs together with names against them, and then you can apply those inbound or outbound on the VXC. So when you apply them to the VXC, you choose from the list of ACLs that you've created, and you can choose whether that ACL is applied either inbound or outbound, so the traffic coming into that interface or out of that interface. The ACLs themselves, the packet filter lists themselves, support IPv4 and IPv6. So in the same list, there's not separate lists for those. You basically just enter the source and destination IPs, and they can be either v4 or v6. When you create the rule, you can also choose the protocol. So it can be TCP, UDP, ICMP, or you can choose to specify a custom protocol, and you can provide the protocol number for that. For TCP and UDP, we obviously support ports as well. So you can specify the source and destination port, but you can also specify a range of ports. So particularly useful for that return traffic scenario if you need to specify that you want to accept traffic on all ports. So the diagram here kind of gives you an idea of where this is applied. So you have the MCR in the middle, you have a VXC off each side, and you can apply back the packet filters to each interface. So within the configuration of the VXC, because that's also where you configure the interface details, that's also where you configure the IP and BGP and all that kind of thing for that interface. That's also where you can now apply a packet filter to that VXC, inbound or outbound or both. This particular scenario might not be immediately obvious why you would want this, but when you start to think about MCR sitting in the middle of a lot of different things, it maybe becomes a bit more clear why you would potentially want to have some control over exactly what can talk to what. So just in this little example here, I've got an MCR sitting in the middle, connected off to 3 different cloud environments, also connected to a data center and to a branch and to the internet. And that's probably one of the big drivers for this as well, is that recently, a couple of months ago, maybe 6 to 9 months ago, MCR is now able to have an internet connection delivered directly to it. And so therefore, obviously, people are keen to be able to control exactly what can go in and out of that connection. But if you imagine this scenario where you've got multiple different environments all connecting to the MCR, some of which may even be public, it becomes more and more important to be able to control exactly what can enter and egress each of those interfaces and be pretty granular about that. So not just this interface can talk to this interface, but this particular IP address on this interface can talk to this particular port on this IP address. So it's good. It's pretty granular. It does pretty much what you would expect from layer 3 and 4 firewalling, and it definitely opens up some more use cases for MCR that were a little bit more challenging beforehand. Some of those are things like maybe you want to use the same MCR to connect to different environments, say like a dev test environment and a prod environment, but you want to make sure that those environments can't talk to each other. There could also be use cases where you've got potentially partially external environments. Maybe you're connecting into some type of service provider and you only want to be able to access that service provider from some particular range of IPs or interfaces internally. You don't want sort of open access between that service provider and your internal subnets. There's a bunch of different use cases here that come up, right? That things that customers have asked for and wanted to be able to do that this facilitates. Okay, so we will jump into a demo and basically run through deploying an MCR and some connections, and then creating a packet filter and applying that to some of the interfaces. So first thing that we will do is create an MCR. And so let's create an MCR in Sydney, just for the sake of the example. So we can choose the speed for the MCR. Something else to note here is that not in this particular location, but we do now have MCR available above 10 gig. So we now have 25, 50, and 100 gig per second available for MCR in quite a few locations. Okay, and we'll order that MCR so it can start spinning up in the background. As with all the services, and as usual, these typically take about 60 seconds to provision, and same for the connections that we'll create off of the MCR. So first thing we'll do here is we'll add a connection to the MCR. We'll add an internet connection. So this is pretty new. Some people may not have seen this before, but you can actually create an internet connection now directly from an MCR. So same rules apply as the Megaport internet service delivered to a port, minimum of 20 meg, and then all the way up to 10 gig, or the size of the MCR. So because we deployed a 1 gig MCR, we're limited to 1 gig. But if this MCR was 10 gig or larger, we could provision up to a 10 gig internet connection. So because we know the details for this, we don't have to fill out all the IP address and everything like that for the MCR. It'll just automatically configure itself based on what's provided as part of the internet connection. So I'll order that so we can start provisioning in the background. Okay. So next we'll add a connection to cloud. Let's go AWS just for the demo. Let's call this direct connect to AWS. And this one can be 100 meg. So again, with AWS in this case, we can automatically configure the IP and BGP and everything else because we know the details. We can integrate with the AWS side to pull all of that that information. Okay, and we'll kick that one off as well. All right, so now we've got the MCR deployed. You can see it's gone green, so that one's up and ready to go already. We've got the internet connection provisioning right now. We've got a connection to AWS provisioning right now as well. What we will do is we'll also create a port. So let's say that we, as well as connecting to the internet and to AWS, let's say we also wanted to connect this this MCR to a data center in Sydney. So maybe we choose Digital Realty just for the example. We can do a 10 gig port there, and let's call this a DC port. So I'll create a port in Digital Realty. Okay, and then what we'll also do is we'll create a connection from the MCR to that port in the data center. So let's call this one to DC. And this one can be 100 meg as well. Okay. All right, so for this one, we would configure the IP and BGP details here because connecting to your own device in a DC, we obviously can't automatically provision the layer 3 configuration, but that's basically where that is. So we'll drop this one in and we'll order those two services. All right. So just to recap, what we've built here is we've deployed a cloud router in Sydney. We've deployed a connection from that private connection from that cloud router to AWS via Direct Connect. We've deployed an internet connection to that cloud router as well. We've created a physical port that we can patch into in Digital Realty in Sydney, and we've created a private circuit between that physical port in Digital Realty to the MCR that we created. So that MCR now has 3 interfaces coming off of it. So if you imagine that as a router sitting in the middle with 3 interfaces coming off of it, each one with its own IP address configured, each one with a BGP session configured. That's sort of where we're at the moment. So this is all stuff that's always been there. So the new part is if we go into the MCR at the top level here, you can see there's a new section here for packet filter lists, and that's where this new functionality is. So in here, we can create these ACLs. So we'll give it a name. Let's call this one something like cloud inbound. And let's say that for the cloud connection, so this is going to be our connection to AWS. Let's say that we want to permit traffic from 10.0.0.0/24. And we want to allow that traffic to 192.168.0.0/24. So let's say that's our data center subnet. Let's say that we want to permit all traffic. So we just want to allow all traffic from the cloud to the DC. But let's say we also have a mail server, for example. So we also want to permit 10.0.0.25 to be able to send mail to anywhere, and we want it to be able to send out to the internet. So let's say we want to send to 0.0.0.0/0. But for this one, we just want TCP. We're going to have any source port, but we just want to allow traffic to destination port 25 for mail, and we can call that rule SMTP. We can save that list. So we've now got a packet filter list in this drop down here. What we will also do, we'll go new list, and let's call this one, let's say, maybe internet outbound. And so we'll apply this one outbound to the internet interface. And for this one, we can basically say that we want to allow 192.168.0.0/24, which is our DC subnet, to anywhere. And we want to allow all traffic. And let's call this something like DC out to internet. Cool. And we also want to allow our mail server out. So let's go 10.0.0.0.25. Cool. And anywhere. And we want to allow destination of 25 and any source port. Okay. I'll call this one SMTP out. Okay. All right. So now you can see that we've created two packet filter lists here, 2 different ACLs at the top level on the MCR itself. So what we'll do now is we'll jump into the configuration of the actual VXCs, so each of the different interfaces. So from the Direct Connect interface, the Direct Connect VXC, if you go to the interface configuration here, we can see the IP that's been configured on the interface. We can see that BGP is also being configured on the interface. So this is where all the layer 3 config is for this particular interface that faces the cloud. And there's a new section here in the middle where we can apply these packet filter lists, these ACLs. So we can see the ones that we created earlier for this MCR. So for this particular interface, it connects to AWS. We're going to apply the ACL we created that's called Cloud Inbound and hit save. So you can apply an outbound ACL as well. They can be the same or different or nothing at all, up to you. One thing to note here is basically that as MCR is a router, when no packet filter at all is applied, all traffic is allowed. But as soon as a packet filter is configured, any traffic that's not allowed in that packet filter will be dropped. So you don't, there's kind of a default deny, an implicit deny at the end of the packet filters. Okay, so we'll close that one. We'll also jump on to the internet VXC here and go to AND, and again we can see the IP address that's being configured on the interface here. In this case, it's a public IP. We can actually see that NAT is enabled on this internet interface. So any traffic going out this interface will be NATed to this IP address. And in this case, we can apply our internet outbound ACL to this interface and hit save. Cool. All right, so that's that. So it's pretty quick and easy, really quick and easy to spin up an MCR, create connections to wherever you need. But now it's also really, really easy to add an ACL to that. So you can be pretty granular about exactly which resources can talk to which others and which ports and all that kind of thing. So this solves a pretty big challenge for a lot of customers on how they can do that basic firewalling without having to jump all the way to MVE and take on the management responsibility for that appliance and provide licensing and all that kind of thing. Kind of gives you that really quick cloud-like, one-click hands-off type of management option to be able to do some basic firewalling at the same time. So this opens up a bunch of new use cases for MCR. Especially bearing in mind that we have that internet connectivity available as well on MCR. So this really starts to come into play in that type of scenario. All right, that's it. So we're nearly at the end of the half hour. Yeah, if you've got any comments, questions, anything like that, feel free to drop them through on YouTube or reach out to your account manager. And we will see you next week.